Welcome back for our final installment of the 22nd Annual Black Hills Model Engineering Expo. Let's get going. Next up, I had the good fortune to meet Paul Knapp. Paul and Paula Knapp run the Miniature Engineering Museum in the Tucson, Arizona area. While being a curator, Paul is also an accomplished builder. Paul brought his rotary engine that is one of a kind, also his radial engine, which is a work in progress. Paul also presented a few of his V8 engines, as well as some race engines in his collection. The fit and finish of these engines is second to none. The attention to detail is amazing. Let's have a look at these incredible engines. Paul's rotary engine was spectacular. When you make a model engine, there's certain realities you can't get around. Electricity at high voltages will jump a gap. As you shrink an engine, it jumps gaps that were never present on the original one. In wiring this engine, Paul had tiny spark plugs that went down to a distributor. These tiny plugs were very close together, and actually the spark, or the electrical charge that was used to spark the plug, would jump from one wire to the next or from the wire to the housing. Paul had to solve this problem. What he discovered was Teflon tubing. Teflon tubing has a remarkable ability to resist electrical currents going through it, so the electric wiring for all these spark plugs, wherever it gets close to something else, is covered in a tiny Teflon tube. With this tube, he could transmit his high voltages down these wires and be assured that the only place where the spark was the end of the plug. Again, model engineering has people solving incredible problems all the time, and the solutions are amazing, and the skill that goes into these engines is spectacular. This engine is a rotary engine. You may have heard of radial engines, but this engine is unique. Here, the pistons are arranged in a circle, but the pistons and the prop rotate together. So essentially, the way I look at it is the entire motor rotates and the shaft is attached to the airplane. Quite an arrangement. In a radial engine, the pistons are also arranged in a circle, but the propeller is attached to the shaft. So the pistons do not rotate, and they are fixed to the airplane, and the shaft rotates with the propeller. Paul's quite proud of this rotary engine. And Paul, forgive me if I don't get this right, but as I understand, this is the only working model of a rotary engine, and it's also the only rotary engine model to ever power a model aircraft. Both records that Paul is proud of. This is the Bentley BR2 rotary Aero engine. Paul constructed this model with the help of Lou Blackmore's book. The engine is machined from stainless steel with aluminum cylinders and heads. The engine burns regular gasoline on spark ignition and has a pressurized lubrication system and a carburetor like its full counterpart. The rotary engines of World War I rotated with the propeller. The hollow crankshaft that extended from the back of the engine was fixed to the airframe, and the crankcase was attached to the propeller. Thus the crankcase and the cylinders rotated with the propeller about a stationary crankshaft. Although you may not recognize it, this engine is incomplete. Paul's working on this Pratt & Whitney R985 Wasp Jr. It's a quarter-scale model. It's a replica of a 450 horsepower engine made by Pratt & Whitney from 1930 to 1963. The model, when finished, will be like its big brother. It'll burn regular gasoline, it'll have dual spark ignition, it'll have a mechanically driven supercharger, and it'll utilize a dry sump lubrication system. Paul estimates the engine's 15.8 cubic inch displacement will produce about 10 horsepower at 4,000 RPM. When he completes this model, he plans to manufacture these engines. This is a Westbury Dolphin overhead valve marine engine. The engine is made from aluminum and bronze castings. It measures 6 inches long, 5 inches wide, and 6 inches high. It weighs in at 4 pounds. It swings a 2 1/4 inch flywheel. It has a bore of 1 inch and a stroke of 1 1/8 inch. It has a total displacement of 0.89 cubic inches and burns petrol on a spark ignition. Here's a Regal direct overhead cam inline 4 speedboat engine. It was designed and built by Jim Regal. This engine produced 4.5 horsepower at 1550 RPMs. This engine was utilized in racing boats and also proved to be valuable in midget race cars. It represented a powerful contender. It had pressurized dry sump lubrication, 2 valves per cylinder, peristaltic oil pump, a water pump, and a fill pump. It burns methanol on a spark ignition. This is a model of a Cratch inline twin. The builder is unknown. Cratch, spelled K-R-A-T-Z-S-C-H. I had to spell it for you just to let you know what I'm up against. Paul supplies spark plugs for model enthusiasts. Talk to Paul if you need a plug for your model. Here his display shows that one of his plugs was first in space. This is a Herkimer OK4 2.4 military drone engine. It was designed in the 1940s. According to the limited information known about this engine, Herkimer scheduled production for a model airplane version of the engine in early 1940s. The modeler's version had a single propeller and a distributor, whereas the military version had a coaxial drive for contra-rotating propellers and dual points at the rear. As the war approached, a few were produced for military drone testing, and 1 or 2 either failed or were destroyed by the Army. Presently, this is the only known example known to exist. This represents a beautiful cutaway of a 5-cylinder radial engine. What a lot of people don't understand is radial engines have to have 5 cylinders to make the mechanism work. This cutout clearly shows the crank, the pistons, and the mechanism in action. Very interesting model that was brought by Paul. Radial engines aren't limited to 5 cylinders, but it must be an odd number of cylinders. Here's a Challenger V8 flathead automobile engine, built by Paul Knapp in 1996. Modifications to the original design include stainless steel water pump, flex fan, and a geared external oil pump. Also added is an oil filler tube with a vent cap, a dipstick, and oil drain plug. The high-rise intake manifold supports dual Walbro carburetors and a single air cleaner. The radiator was produced from a 1965 Mustang heater core and enclosed inside a custom brass-made shroud. It has a bore of 1 inch, a stroke of 1 inch, and a total displacement of 5 cubic inches. It burns unleaded gasoline and has spark ignition. The Rusty Nail Robotics team provided us with 2 robots at the show. This robot was produced for a national competition. It actually was assembled just yesterday, the day prior to the show. The team plans on entering it into a contest. New Underwood, South Dakota is a community that's just outside of Rapid City, and the project was accompanied by the instructor as well as one of the team members. I'd like to thank them for coming to the show. So what's next for model engineering enthusiasts? In Estevan, Saskatchewan, there'll be a model engineering show on October 15th and 16th, 2022 at the Wiley Mitchell Building at the Estevan Fairgrounds in Estevan, Saskatchewan. With that, I hope you enjoyed this presentation of the 22nd Annual Black Hills Model Engineering Expo. I'd like to thank all those who were in attendance and those that arranged the show. The venue was excellent, the facilities were superb, and the camaraderie was a gift. I'd like to thank the Rapid City Model Club for attending. I'm particularly grateful for all the machinists not recognized in this video because there were many. I dedicate this production to my grandnephew Cam, who likes all things shiny and twirling. I hope to see you next year at the show as I bid you adieu.